Okay, so we're in section 1-6. We have two situations. One is a substitution. And all things being equal, in order to do a substitution, you have to have a substitution. Y over x is equal to u is our normal substitution. That's the one we always use first, unless the book tells us to use a different one. And that's why I don't go deeper into the problem set, because deeper in the problem set you'd have to guess on the substitution to use. So the substitution problem on the test that you're going to have for chapter 1, I will tell you what substitution to use. So don't make it up, use the one that I told you. The other thing we're going to do is exact form. And it turns out that if I have some function in x of y plus some other function in x of y, and if it turns out that the partial of the m guy with respect to y is equal to the partial of the n guy with respect to x, if those guys are equal, then I can solve this problem. It's in a form that's called exact mode, and I can solve that problem. So those are the two things we're going to do today.
Were those twos that were in front of the n?
Those are partial derivatives.
Okay.
Yeah. So that was a partial derivative with respect to, because if you have two variables, you have to say what the derivative is with respect to. Okay. So if I have a function y squared plus 2x plus 3, and I take the derivative of that with respect to x, that form would not make any sense. But if I took the partial derivative of y squared plus 2x plus 3 with respect to x, that would be the right form, and the answer would be 2. So because when I take the partial derivative with respect to x, the y components are treated as constants. But it wouldn't be, this would not be a proper form, the derivative of that with respect to x. That would not be a proper form. If I did this, I would expect that this is some function with respect to y. Then I could do it, and then I would say 2y of x times y prime of x plus 2. I could do that. That would be the proper thing to do. But if I want if I'm doing that, I have some function in x and y, and they're not related to each other, then I have to do that. All right. So that's English. All right. So we'll start in the problem set with number 2. All right. So I got number 2, and we're going to do these guys by substitution. So I have 2xy y prime is equal to x squared plus 2y squared. So I look at that and I say, well, I can't put that in the form y prime plus pxy plus qx. I can't use that form. I can't separate the variables. No matter what I do, I'm not going to be able to separate variables, so I got to do something else. So what I'm going to do is I'm going to do a substitution. I'm going to say u is y over x. Well, if u is y over x, then y is ux, and y prime is going to be u prime x plus u. Okay, that makes sense? Can I do that? All right, now that I've done that, I'm going to substitute into the formula. I'm going to have 2x times ux, that's my y, times u prime x plus u is equal to x squared plus 2 times ux squared. All right, did I do anything wrong yet? Probably not. So I've got 2ux squared and I've got u prime x plus u is equal to x squared plus 2 u squared x squared. And I look at that and I say, well, I can divide every single thing by x squared, and now I could rewrite that as 2u u prime x plus u is equal to 1 plus 2u squared. This is 2u squared sitting there when I multiply it, right? So now I say, well, that guy goes away, this guy goes away. And now I have 2u du is equal to 1 over x dx. I now have separated variables, and I can integrate both sides of my equation, and I can have that u squared is equal to the natural log of x plus some constant c. Okay? Excellent. Now I'm going to substitute back. And I remember that u is equal to y over x. So I'm going to substitute back and say that y squared over x squared is equal to natural log x plus c, and y squared is equal to x squared natural log x plus c x squared. And I'm going to have the y of x, and this is going to be my final answer. Final answer is equal to plus or minus the square root of x squared natural log x plus cx squared. All right, and then you're asking yourself, how am I going to check this? And so I go back to the original problem, and I would say, well, looks like back of the book check is good enough to me, right? So we'll do a back of the book check. And this is section 1.6. 1.6 number 2. And I have y squared is equal to x squared times the quantity natural log x plus c, which is exactly what I had there before I changed it to something else. So we check with back of book. Okay, easy enough. I guess I'm going to apply the substitution, get it. I can only solve differential equations two ways: separation of variables, or I have a first order guy where I have y prime is equal to pxy plus qx. Those are the only two ways. I do a substitution, get into one of those other two ways, and then I'm done. And then I substitute back. All right, so we'll try it again. Number 4. X minus y prime, x plus y. And I look at that, and I try to figure out whether or not I can separate variables, or whether or not I can do anything at all. And it looks like I'm pretty hosed, right? So we'll do a substitution, and we'll say u is equal to y over x, y is equal to xu, and y prime is u plus u prime x. And then we substitute that in. X minus xu times u plus u prime x is equal to x plus xu. Okay, looks like I've got xu plus x squared u prime minus xu squared minus x squared u prime is equal to x plus xu. All right, well, there's an x plus xu, there's an x plus xu. I see an x there, one there, one there, one there. And when I get done, I have x u prime minus u squared minus x u prime is equal to 1. And I look at it a little bit, and I say, what are we going to do about that? Let's see, if I had x u prime minus u squared minus x u prime minus 1 was equal to 0, could I factor that? And doesn't look like I could. I'll back up some. If I had that, I could say x times u prime minus u prime. No, I could say x u prime times 1 minus u minus u squared is equal to 1. I don't see where that helps any either. I think we were better off. X u prime minus u squared minus x u prime minus 1 is 0. Minus 2 is 0. There's 2 there, right? 1, 2. Minus 2 is 0. So if I add x u prime times 1 minus u, there's that guy, there's that guy, and then I'd have to have a plus u there. I still wouldn't have a 2. Alright, so let's come back to the substitution. I have an x, I have a y minus xu, I've got a u plus u prime x is equal to x, and then I have an xu. So I did the substitution right. I multiply it out, xu. Oh, that's where my problem is. Okay, so I've got an xu, I've got an x squared u prime, I've got a minus xu squared, I've got a minus x squared u prime. Okay, so I have all that stuff, right? Now, when I take those two guys away, they're not there anymore. So they're both gone because, okay, so they're gone, boom, boom. I divide by x. He's gone, he's gone, he's gone. I have a 1 there. So this is a 1, not a 2. Okay, so I got an x u prime. I got a minus u squared. I got a minus x u prime. All right. So it looks like I'm back to that being a 1. Does that help me any? How do I get a u squared unless I go u times u? x u prime times u gives me that guy. But then I'd still, okay, I could factor it with a 1 being there. So if I factor it with, I have x prime u, I have a u, I have a minus u, but if I put a plus 1 there, I've got a x times u prime minus x minus u prime minus u squared is 1. I've got an x u prime minus u prime is equal to 1 plus u squared. I've got a u prime minus u prime divided by 1 plus u squared is equal to 1 over x. I've got a 1 minus u divided by 1 plus u squared du is equal to 1 over x dx. One of the things that we do, Scott, is try to skip as many steps as possible so that the student is as confused as he can be. So if you're confused, that's perfectly okay. Okay, now we're there. Now I can integrate both sides. Well, that's one way to look at it, right? All right, well, this side, I can get this side, natural log x plus c. Now, what am I doing over here? I got the integral of 1 over 1 plus u squared minus the integral of u over 1 plus u squared du du. Okay, so for this one, I'm going to want a 2 here, a 1/2 there. All right, so the integral of 1 over 1 plus u squared du is tangent u, right? Tangent u minus natural log of the square root of 1 plus u squared is equal to natural log x plus c. All right, now I've solved the equation, and I'm going to resubstitute back in. So u is equal to y over x. I'm going to have natural log of y over x minus the natural log of the square root of 1 plus y over x squared is equal to the natural log x plus c. All right, and we do a check in the back of the book, and we see that we're 100% correct. And pretty much, they're doing an arctangent. So this is not tangent, this is arctangent. So arctangent, and instead of doing that, they multiplied everything by 2. So they've got a 2 here, they've got a 2 there, and they don't take the square root, which is our answer. Okay, so when we manipulate it like that, then it checks with back of book. So what they did is they, instead of leaving the 2 there, making that a square root, they multiplied everything by 2, and then they wouldn't have to do the square root inside the natural log. Okay, that's 2 out of 2. Looking at number 6. Are you supposed to, yeah, you're supposed to be doing every odd. Okay, so I'm looking at number 6. X plus 2 y prime is equal to y. Yeah, all right, so we'll, don't say anything right to do right away. So I'm going to go and say u is equal to y over x. Y is equal to xu. Y prime is u plus xu prime. So I'm going to do that substitution. X plus 2 times xu times u plus xu prime is equal to xu. Okay, so I've got xu plus x squared u prime plus 2x squared u squared is equal to xu. The 2xu's go away. Okay, so I've got x squared u prime plus u squared is equal to 0. Yeah, that's what I got, is equal to 0. So, oh, what 2? Where's the 2? 2 is equal to 0. I can divide by x, right? So I got u prime plus 2u squared is equal to 0. So I got u prime is equal to minus 2u squared. I've got du divided by 2u squared is equal to minus dx. We'll leave the 2 on this side, and we'll take the 2 away from that side. Alright, so I'm going to integrate both sides, and I get that on this side I got minus 2x plus c. Alright, I'm going to get minus 1 over u on this side, right? Yeah, the derivative of minus 1 over u would be 1 over u squared, so that'd be correct. Okay, now I'm going to substitute back. Minus 1 over ux is equal to minus 2x plus c. Okay, I'm going to invert. X over y is equal to 2x plus c. Y is equal to what? X over 2x plus c. Cross multiply, and then I'm going to invert. So y is equal to, I guess I'm done. Yeah, I can't do anything with that. Y is equal to 2x plus c. All right, so we look in the back of the book, in number 6. Okay, looking at number 8. I've got x squared y prime x y. Oh, you gotta be kidding me. X squared e to the y over x. You gotta be kidding me. I gotta do that? Anybody want to go to the board and solve it for me? Okay, we're going to use u is y over x, y is xy, xu, and y prime is u plus u prime x. Okay, so I got x squared u plus u prime x is equal to xu plus x squared e to the xu over x. Okay, so I got x squared u plus u prime x cubed is equal to x squared u plus x squared e to the u. Okay, so I got one there, they go away. I have an x squared here and an x cubed there. So I end up with du dx, which is the y prime, is u prime, is equal to x. This is an x. I still have an x there. Is equal to e to the u. Okay. So I've got du divided by e to the u is equal to dx divided by x. I'm going to integrate both sides. And on this side, I'm going to get natural log of x is equal to plus c. Now, what is the integral of e to the minus u du? That should be minus e to the minus u, right? So that should be minus e to the minus u. Okay. I'm going to substitute back in. I'm going to say minus e to the minus y over x is equal to natural log x plus c. Now our first inclination would say take the natural log of both sides, right? I'm not so sure. That's number 8.
Yep.
Oh, wrong place. Y is minus x, natural log of c minus xu. Okay, so we're there. We got it right. That's all that matters. Okay, we're going to go and change this to e to the minus u over x, y over x is equal to c minus natural log x. We're going to take the natural log of both sides of the equation, and we're going to have minus y over x is equal to natural log c minus natural log x. And then we're going to say y is equal to minus x natural log c minus natural log x. And at that point we're going to say, oh, that's what the back of the book has. We're just so wonderful. Check back of. Okay.
The negative in front of the e's go away then.
The negative
When
in
you make the natural log.
no. This guy here?
Would that be a positive?
No. First of all, I can't take the natural log of a negative number. Okay, so that negative went away when I multiplied both sides by minus 1.
Okay.
So I multiplied both sides by minus 1, so that I have c minus the natural log, and that allows me to have the possibility of taking the natural log of a positive number. All right, now, can I take the natural log of a negative number? No, I can't. But that what you're going to find out in your complex variable class is that's only true if that's on the real number line. So if I have an imaginary axis, I, and a real axis, the only place that that's true is here on that number line. So if I have this point right there, which is, and say the natural log of -1 plus I can take that natural log of that number. Okay, but I can't take the natural log of something on the real negative number line. That doesn't work. Okay, but it won't be until your complex variable class that you encounter that situation. And then maybe somebody will explain to you why. Was that was 8. Okay, we'll try 10. 10. X, y, y prime. X squared plus 3y squared. Okay. Now we're using a substitution. U is y over x. Y is xu. And y prime is u plus xu prime. Okay, so I've got x, xu, u plus xu prime is equal to x squared plus 3 xu squared. Okay, I got x squared u squared plus x cubed u prime is equal to x squared plus 3 x squared u squared. Okay, so I've got x cubed u prime is equal to x squared plus 2 x squared u squared. Okay, I got a 1 sitting there. I got that guy and this guy going away. Okay, so now I got x u prime 1 plus 2u squared. Okay, I got u prime 1 plus 2u squared divided by x. I've got u over 1 plus 2u squared du is equal to 1 over x dx. Now I'm going to integrate both sides. On this side I have natural log x plus c. On the other side I have the integral of u d, no I don't. No. Okay. I have the natural log of 1 plus 2u squared. But if I take the derivative of this, I would have 4u on top. So I need a 4 there, and I need a 1/4 here. So this would be raised to the 1/4 power. Okay, well, I guess I'll just make these exponents of e, and then I would have the 4th root of 1 plus 2u squared is equal to cx. Cx? Yeah, I guess so. And I'll substitute back. So back. The 4th root of 1 plus 2 y squared over x squared is equal to cx. Maybe the author left it that way, maybe he didn't. This is number 10, and he didn't leave it that way. Okay, well, be that way. We're going to go and take everything to the fourth power. 1 plus 2 y squared over x squared is equal to cx to the fourth power. Two y squared over x squared is equal to cx to the fourth power minus 1. 2y squared c x to the sixth power minus x squared. Y squared is equal to x to the sixth power, cx to the sixth power minus x squared over 2. And then we could take the square root of that, but I don't think the author did. Number 10, in fact, he stopped back here. Yeah, he stopped right there. So this is back of book, and we got the right answer again. Okay, excellent. Why don't we do one with cosines in it? Why don't we not? Why don't we start doing the exact ones? That's what we'll do. Okay, so this is the theory. And the exact thing, where is it? Okay, on page 68. It says, if I have two formulas, m of xy, I have two guys, m of xy and n of xy. And I have something that's m of xy dx plus n of xy dy is equal to 0. So if somehow I got into that form. And I could show that the partial of m xy with respect to y plus is equal to the partial of n xy with respect to x. Then m, the partial of m with respect to x would just be some u xy. Okay. If the mixed partials are the same, then these two guys and the partial of n with respect to y. No, where's my eraser? Then the partial of u, there exists some function, the partial of u with respect to x is going to be my m of xy. And my partial of u, that doesn't look much like a partial sign, does it? Looks like I don't know what it looks like. The partial of u xy with respect to y is going to be n of xy. Okay, so all of that is true. Now, how does that apply to any problem we're doing? Well, that's the issue. So we'll start with number 32. And we have 4x minus y dx plus 6x minus 6y minus x dy is equal to 0. So what we'll look at to see if the method works, we're going to look at the partial of 4x minus y with respect to y we get a minus 1. And we're going to look at the partial of 6y minus x. With respect to x, we get a minus 1. Now the mixed partials are equal, so the partial of u with respect to x, respect to y, is equal to the partial of u respect to y, respect to x. That being the case, there has to exist a function u, the partial of u with respect to x, has to equal the m guy, 4x minus y. 4x minus y. So the partial of u is equal to 4x minus y, the partial of x. I integrate both sides, and I get that u is going to be 2x squared minus yx plus some constant that's in y only. Okay, it's not a constant in that it's a number, but it's a constant in y only, because when I take the partial with respect to x, it goes away. Okay. Now, I'm going to take this guy and I'm going to say, what is the partial of u with respect to y? So that guy goes away. This becomes minus x plus the derivative of the constant. Well, what is that equal to? Well, that has to be equal to the n guy, 6y minus x. 6y minus x. It has to be equal to that. Well, I've got a minus x on both sides, so c, the constant in y only, has to be 6y. So the derivative of y there's a derivative of c with respect to y. Derivative of c with respect to y has to be 6y. So the derivative of c is 6y dy. I integrate both sides. And this constant in y only is going to be 3y squared plus another constant, we'll call it k. Okay, so now I'm going to write down my final answer. Final answer. U of xy equals, move back up, equals 2x squared minus yx, 2x squared minus yx plus 3y squared plus k. Okay, now we're going to check our work. The partial of u with respect to x is 4x minus y. The partial of u with respect to y is 6y minus x. Go back to the original problem. 4x minus y, 6y minus x. My solution checks. Check.
Can you go back up to the top a little bit?
Oh, yeah. Obviously, you're going to see this problem on your Chapter 1 test, a problem similar to this. So what we're doing, we first check that the mixed partials are equal. Okay, given that they're equal, the method works. Okay, so we say that the derivative of u, which is what I'm solving with respect to x, is 4x minus y. We then solve for u. Once I solve for u, I take the derivative of u, partial of u with respect to y, and solve for the constant c of y. Once I have the constant c of y, I just add it back to my original expression for u, and then I have the final answer and then I check my work by taking the partial derivatives with respect to x and respect to y to make sure I get the same thing back that I started with. So, you want me to stop talking and just move it up?
I think you want, yeah, what's the top?
All the way?
No, wait, right there. Up a little.
Up a little bit is where we're checking the mixed
So
partials.
those, the middle, like the two at the bottom, there you go, right there. Up a little one, there you go, right there.
Okay. So I'm checking that my mixed partials are equal. If they are not equal, then I can't use this method and I have to go to do something else. I don't have a choice.
All right.
All right, so I'm doing number 34 next. Now someone better tell me I'm supposed to be using this method before I start working the problem, right? I can't out of the blue decide to do this. So I'm going to have to be in this section. I'm going to have the person writing the exam tell me that he wants me to use this form in order to do the problem. Otherwise, I'm going to have to punt. Plus 2 x squared y plus 4 y cubed dy. All right, so I'm going to look at the partial with respect to y of 2xy squared plus 3x squared. And I'm going to get 4xy. And then I'm going to look at the partial with respect to x of the other guy, 2x squared y plus 4y cubed. And I'm going to get 4xy. They're equal, therefore the exact method works. All right, now that I know that it works, I know that the partial of u with respect to x is the first guy, 2x y squared plus 3x squared. Okay, so the partial of u, that's a capital U, 2x y squared 3xy partial x. Integrate both sides. So u, and we'll throw in u of xy if you want to do that, is equal to x squared y squared plus x cubed plus some constant in C only. Okay, and then I'm going to go and take the partial of u with respect to y. 2x squared y plus the derivative of the constant. And that has to equal the other part of the equation, which is 2x squared y plus 4y cubed. That being the case, the derivative of c with respect to y has to equal 4y cubed. The derivative of c, the constant, has to be 4y cubed dy. I integrate both sides. C of y is going to equal y to the 4th plus some constant k. Okay, so final answer, u of xy is equal to x squared y squared plus x cubed plus y to the fourth plus k. I'm going to check my work. The partial of u with respect to x. 2x y squared plus 3y squared, 3x squared. The partial of u with respect to y. 2x squared y plus 4y cubed. Is that the problem we have? And the answer is yes, it is. And our checking works. It checks. All right. Now, how many times in your life have you seen this particular method worked as a problem? Twice in the last 20 minutes, right? Okay. Clearly, there's going to be a problem like this on the Chapter 1 test. So to work the even number problems and to be able to work this type of problem makes a lot of sense. It doesn't seem that hard. Does it seem that hard? No. Yes, it does. But I'm doing it. It doesn't seem hard. Your Chapter 1 test is open book, open note. So you should have a tab in the book on exact method, so you know what you're doing. And you should have already solved several problems like this on your own. It shouldn't be that much of an issue. Looking at 36. 36. 1 plus y e to the xy dx plus 2y plus x e to the xy dy is equal to 0. Okay, so I'm going to check the partials. I'm going to check the partial of 1 plus y e to the xy with respect to y. E goes away. I have e to the xy plus x, y, e to the xy. I look at the partial of 2y plus x, e to the xy with respect to x. Okay, this is just a constant, it's 0. So I have e to the xy plus xy e to the xy. So those two guys are the same. So my mixed partials are the same. So my method works. Okay, so now we're going to take the partial of u with respect to x has to be the first guy, x plus 1 plus y e to the xy. And I'm going to take the partial of u, 1 plus y e to the xy, partial of x, integrate both sides. So u of xy has to be x plus e to the xy plus some constant in y only. Yeah, I guess that's what it is. All right, now I'm going to take the partial of u with respect to y. That guy goes away, he's just a constant. This guy here is going to be x e to the xy plus some constant the derivative of the constant in y only. That has to equal the other half of the equation, which is 2y plus x e to the xy, implying that c prime y has to be 2y. Okay, so dy, dc, the derivative of the constant in y only has to be 2y dx. I integrate both sides. The constant in y only is going to be y squared plus k, some other constant. Final answer. U of xy equals something. What does it equal? X e to the xy plus y squared plus k. Okay, so that's my final answer. I'm going to check my work. The partial of u with respect to x, 1 plus y e to the xy. The partial of u with respect to y, he goes away, 2y plus x e to the xy. Is that what we started with? And the answer is yes. So it checks. All right, so our answer is good. And now it's time to do it with 38. About time we get some sines and cosines, right? We want some arc cotangents and arc cosecants. We don't want any of these simple things. Well, anyway, 38. We'll get them soon enough, it won't matter. Okay, so I've got x plus the arctangent of y dx plus x plus y over 1 plus y squared dy is equal to 0. Now I gotta check the mixed partials. Me and what are me? Minus 1 arctangent of what? Y. Okay, so the partial of x plus tangent arctangent y with respect to y equals. Right, so what is that? Is it 1 over 1 plus y squared? Is that what it is? I think that's what it is. The derivative of arctangent. It's probably in the front of the book, and I'm looking in the back of the book. What are all these empty pages in the back of the book about anyway? Arctangent. Yeah, that's what it is. 1 over 1, yeah. So number 18. So if I take the derivative of the arctangent of y, I'm going to get 1 over 1 plus y squared. Okay, that's good. All right. Now I'm going to take the partial of x plus y over 1 plus y squared with respect to x. Okay, so that's going to be, okay, so this is just a constant. That's just a constant. So that's just going to be 1 over 1 plus y squared, right? Check. So the mixed partials are the same. All right, so that's good. I'm glad to hear that. Now, Do I want to take the integral of the arctangent? Oh, no, I don't particularly want to take the integral of the arctangent. Okay, so what I'm going to do is I'm going to take the partial of u with respect to y is equal to x plus y over 1 plus y squared. Okay, so that means the partial of u is equal to x over 1 plus y squared plus y over 1 plus y squared. Partial y. Integrate both sides. U of xy equals, okay, so this integral is an arctangent guy, right? So this is arctangent, this is x arctangent y plus 1/2 natural log 1 plus y squared plus some constant in x only. Is that what it is? Okay. Now I'm going to go and take the partial of u with respect to x. Okay, and I'm going to get arctangent y. The partial of this with respect to x is 0, it goes away, plus c prime x, which implies c prime x is equal to c prime x is equal to x. Is that what it is? Yeah, it's equal to x. So dc is equal to x dx. C of x is equal to x squared over 2 plus some constant k. Final answer. Final answer. U of xy equals x arctangent y plus, why don't we make that 2? 2x arctangent y plus natural log 1 plus y squared plus x squared plus k. So I got a 1/2 here, and now I'm just multiplying everything by 2. Can I multiply everything by 2? Is that okay? All right. Now I could take those partials one at a time, right, and see what it was, but that looks like a total pain in the backside. So we will go and check on this problem. This is 38, is that what it is? We're all the way up to 38 already? And it says I should have x squared, which I do. I should have 2x arctangent y, which I do. Natural log of 1 plus y squared, which I do, plus a constant, which I do. All right. So check with back of book. Now notice what I did different this time. I decided that because I didn't particularly want to take the integral of this guy, I would take the integral of that guy first. It's perfectly okay doing the partial of u with respect to y first, as long as you remember your constant is in x only if you do that. So I worked on this guy first because he looked like the easier integral. Then to work on that guy would look sort of like the harder integral. But he wouldn't have been the harder integral, would he? because I would have, yeah. No, that wouldn't have been a harder integral to do, because the natural law, the arc tangent y is just a constant with respect to x. So I guess I may have gone the hard way. Maybe.
Can you go down a little bit on that one?
It all depends. You want me to,
Where it says like a u of x y, that one?
Yeah.
Okay, when you multiply that by 2 at the end, how come you have to do the c of x?
well, I didn't multiply it by 2 at the end until I got to the end. So the issue is, what is c? Constant of integration, right?
Mm.
What's 2c?
Constant.
Just c. What's c squared?
Same thing.
Just c.
So it doesn't matter.
What if I had the tangent of c? What is that? Just c. So until I apply the initial condition, my constant of integration is just that. I don't know what it is. It's an unknown. It's just a constant of integration. It doesn't matter if I take the arc tangent of c or not. Until I apply the initial condition, I can't follow. I don't know what it is.
Okay.
So it continues to be an unknown. So there's no difference. If c is your constant of integration, that is the same as that, is the same as this, is the same as that. Until I apply the initial condition, I don't know what it is. It's something I don't know. Now, when I do that, I say I'm playing fast and loose with c. Okay, which is what I'm doing. So if I had something that was 2x squared plus c, then when I wrote my final answer, I'd say that's 2x squared plus c. I wouldn't say it's 2x squared plus 2c. Why would I bother? I'm wasting ink. Okay, so that's English. That's spelling. Yeah. Well, does 40 look wonderful? Are we supposed to go that far? Yeah, we're supposed to go all the way up to 49. So should I do 40 or should I do 44? Or should I do both of them? Maybe I should do both of them. 40. We'll do 40 first. E to the x sine y plus tangent y dy dx plus e to the x cosine y plus x secant. Is that a secant squared? Secant squared y dx dy. Anyway, something, d something or other, is equal to 0. Okay, so first of all, I have to check the partial of e to the x sine y plus tangent y with respect to y. That looks like e to the x cosine y plus the derivative of tangent is secant squared, right? Secant squared y. No one's jumping up and down telling me that I'm right. The derivative of secant squared. The derivative of tangent. Yes, the derivative of tangent is in fact secant squared. Okay. And then I want to do the partial of e to the x cosine y plus x secant squared y with respect to x. And I'm going to have e to the x cosine y plus secant squared y. These guys are equal, therefore the method works. Okay, so now I have to ask myself, which one do I want to work on? They both look equally as bad. Okay, so I'm going to look at the partial of the first guy. E to the x sine y plus tangent y no, u partial of x is equal to that. Okay, I got it. So now I'm going to have u partial of u e to the x secant sine y plus tangent y dx. I'm going to integrate both sides. U of xy is equal to e to the x sine y plus x tangent y plus some constant in y only. The partial of u with respect to y, e to the x cosine y plus x secant squared y plus some constant prime of y only. Okay? Now I look at this guy and I see that he's exactly what I have, e to the x cosine y plus x secant squared y. So c prime y is equal to 0. So c of y has to be a constant k. So final answer, y of x, u of xy is equal to x e to the x sine y plus x tangent y plus k. Okay, pretty good. And we don't have to check it because it's so pathetically easy. All right, now we're going to look at number 44. Find a general solution